Okay, this is a solution to the puzzle Fillomino Chaos Construction. We're going to use PenPy to solve this one. And, okay. So, there's two main ideas, two key observations about the constraint that we need to make before we can actually start solving. First is that two circles cannot be in the same polyomino, because if they were, then they have the same number. Let's say these two are together. And we're going to ignore the whole row thing. They're in the same region. Because they're in the same Fillomino and every polyomino is contained in the same, like all polyominoes are contained within one region. So yeah, that's not possible. So we're gonna use green to draw polyomino edges and black to draw region edges. So yeah, this is a 1 because this polyomino just has to end here. It can't go here or here. And the second fact is that squares cannot be in the same region, because if they were, they would count the same number of polyominoes but be in the same region, so that would be a repeat. Okay, so this is 1, this is 2. This polyomino can be at most size 3, so it has to be size 3. And it looks like this. Do 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 do. This guy can't be 1, because if it's 1, then it's saying that this region has one polyomino, which means that the polyomino must have size 9. However, it's also saying that this region has polyomino of size 1, this polyomino size 1, and that is bad. So it has to be 4, 5. And so we're going to have this guy get out here. Black edge because squares can't be in the same region. Green edge because circles can't be in the same polyomino. And now we're going to look at this. Edge. Now, if this were 5, we need to somehow be able to get like 5, or one region would be size 5 and the other 4 regions would have to be size 1. So we'd have to be able to place 4 regions of size 1. And regardless of whether you place it here or here for the 5 polyomino, regardless of how you finish it, this is 1, 2, 3 at most. And this is 1, 2, 3 at most. Sorry, this is actually boop, boop. This is technically 1, 2, 3, 4, but then this guy is stuck. Right. This is technically possible for now, but we're going to notice that this is size 1, and because we see these edges here, this has to have size 1, and that is bad, so it cannot be 5. This guy must be a 4. So now this guy sees a 1 and a 2. It's touching a 3 polyomino. It's touching a 4. So it has to be 5. And now we can draw edges. And this guy goes up to here. Okay. And now what I claim is that these guys cannot be connected in the same polyomino. If they are, then we're gonna have to put something like this here. Because if we put this here, there's just no way to get anything of size 5, or sorry, no way to get our 5 things. If we do this, we can't put 4 regions of size 1, 4 polyominoes of size 1. 1, 2, 3, oh, sorry, we can. Okay, actually, let's just look at all the ways we can do this. This is 1, 2, 3, 4. In fact, I'll use brown just to make it obvious. 2, 3, 4. This is somewhere here. 1, 2, 3, 4. This is 1, 2, 3, 4. So notice that regardless of what we do, if we have this guy here, it's purple, then one of these guys is brown. And the reason this is bad is because, let's say this guy is purple. Um, then this guy has to be a 1. Because if red goes here, it has to be a 1. Because if it's a 5, then you have 4 plus 5 is 9. That gives you 2 regions, and we have 4. So this would be a region of size 1. But that wouldn't be good because this would be a region of size 1. And if this is a 5 polyomino, 1, 2 is not possible. So, and alternatively, if this guy is a Fillomino of size, polyomino of size 1, well, this guy has to be red for the red region to escape. Oh, I should establish that this is a black border. The way you do this is because 4 plus 3 is 7, so we have to have 2 regions size 1. It's not possible. Because these guys can't be 1, because of this guy, and these guys, only one of them can be 1, so yeah, it's a black. So yeah, this has to be red, so this has to be red. So this is a 5 or a 1. If this is a 1, then bad things happen because if this is a 1 and this is a 5, and this, it's because it looks like this. Like, if this is a 1 region, then these guys have to be connected somehow. It's like this, which forces a 1 polyominoes in this purple region to look like that. And this is red, and this is size 1, contradiction. So this is the hardest, sort of, most involved step. And I say it out loud, it sounds pretty long, but it's actually not too hard. Just to see that basically this is not part of the polyomino. So this is. And now we can just look at what's possible. If this guy is a black edge as well, so now we have 2 possibilities. It's easy to see which ones work and which ones don't. This one doesn't work. 1, 2, 3, but fails. So it has to go up here, and 1, 2, 3, 4. And we're going to recolor it purple after we're done explicitly constructing this region. But for now, I think it helps to just lay it out as blue, or sorry, as brown, just so you can see it's a different. The polyominoes are different. Now I'm going to color it purple. So this is a complete region. This is part of a region. This is a region, and let's look at these guys now in this area. This guy is. These guys are both at least 2. So this guy has to go up here. This polyomino has to go climb here. And now this polyomino is trapped. It can't grow any larger, so this guy's a 2. What? Hi? Uh, yo, what is happening? Genre tags classic? Oh, it thinks it's ah, damn it. Okay. Okay, that, yeah, it's a good point. Um, After this video, I'll edit this link. It's conflict detection. I'll turn it off for this puzzle. I should remove the classic setting. It just, even if I remove the edges, it still looks for conflicts in boxes, which is not right. Anyway, you see this has to be in the orange region at the very least. It has to grow out to here. And now this is a purple polyomino, and this guy has to be at least, well, what can it be? It explicitly sees 1, 2, and 4. It touches something of size 5 and size 3, so it's 6, 7, 8, 9. And so this polyomino is at least 4, so it's going to grow. Doot. Doot, doot, doot. And here's an edge, edge. Okay. Now let's look at where the blue region can grow to. It can't be part of the red region. We already established that if you combine these, we don't have anywhere to put. We can't put 2 1 Fillominos without having them touch, so this is a black border. Now this guy can't go in this guy, because if it does, 1, 2, 3, 4, 5, 6, this is a 2, and that's bad. These guys see each other. So this is also a black edge. And obviously, because this region is complete, this is a black edge. In fact, all its edges are black on the outside, so we'll add that now. So this guy has to go up in here. So this is a black edge. So it has to go here. And 3 plus 2 plus 4 is 9, so we have a region of size 9. And this is a 4. And now the orange region is going to grow out. 1, 2, 3, 4, 5, 6, 7, 8, 9, and... Okay, this is at least 3. But it can't be 6. 6 is way too big. And 4 and 5 it sees, so it's just exactly 3. Okay, now let's look at this guy. This polyomino. We'll color it brown. You see it's at least 5, so it goes here. And has to climb out here, but it can't go here. So it has to do this. And then the orange guy has to do this. And now let's look at this guy. This polyomino has to climb out like this, because it's at least 2. And so the brown polyomino has to climb up again. So the orange guy has to do this. And now we've determined the orange region. Oh, and real quick, the orange and the brown region can't be the same, because it were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is bigger than 9. So now we determine the orange region. And this guy obviously has to be a region of size greater than 1, because it is touching a polyomino of size 1. So this is in the same region as this. And this is in the same region as this. So these guys are all in the same region. 1, 2, 3, 4, 5, 6. And to get 3 regions, if we had 7 or more, 7 means that these two touch. These two are 1 phyllominos that touch. That's bad. So this is 6. And somehow or another, this is a 1-2 split. We don't know how. But what we do know is it's either like this, or like this, or it's like this. Regardless, this cell has a 2 in it, because it's in the middle. Okay. So now I want to look at where can 1 go in certain places. Let's look at the blue region. Goes in here, because it doesn't go here in this row. So now let's look at the orange region. Can't go here because it sees here. Can't go here because it sees the blue one, wherever it is. So it must go here, and the blue one has to go here. And this is not a 1, so it's at least 5. Which means that we're going to also color this brown because these two browns are really far apart, so it's okay. That means this is not the same region, because if they were 4 plus 5, 2, or is 9, that gives us 2 regions. We have 4. Similar logic. So we're going to look at how the red region grows and how the brown phylomino grows. Yeah, those are distinct things. Okay. And now this region has size at least 3. Or sorry, at least 2. Now there's 2 places where our next red guy could go. Well, either here or here. And now I want to show it can't go here. It can't go here because, well, these two are part of the same phylomino. And these two are part of the same phylomino. This is a relevant part. These two have to be in the same phylomino. This guy can't be a phylomino of size 1. There's only one place for this phylomino to grow. It can't be size 1 because it's touching the size 1 phyllominos. So, if we make this red, this is at least a 1, this is at least a 1, or sorry, this is at least 2, this is at least 2, boop, and this is at least 2, so we have a 2, a 2, and this guy joins one of them. Or if this is an edge, then we need, basically it's a 2, and a 1. Because this is at least a 2. Or a 2 or a 3, or 3 and a 2, or a 3 and a... Basically, it just doesn't work. Like, no matter what, if you make this red, it just doesn't work. It can't be part of this. This just doesn't work. And if this isn't the case, then you can't do anything jank like this. Maybe a better way to think about this is, okay, we can't do this because if we did this, we'd get this configuration. And either you have 1, 2, 3, 4, 5, which doesn't work because it's at least 2, at least all of these guys are at least 2. The average region size is greater than 2. 5 over 2 is less than 3. And you can't do anything weird like this because this is like, if this is 3, this is 1 and 1, but these touch. If this is 2, this is 3. So, yeah. That's just a very long way to say that this is here. This has to go here. Like, either way you slice it and dice it. Okay, now let's look at row 8. Where can 2 and 4 go? Not in the red region, and not in the blue region. So it has to go here, which means that this can't be in the red region. And we're actually going to pull out the brown region to go here. Okay. This can't be the red region because then we have this. Or, okay, another way to think about this has to be red. Because otherwise you're just confined to this. That's 8. This has to be red. And if this is red, well, at least 2, at least 2. So if this is 2, like, if this is 2, then we have basically, we would need a 1, a 1, and a, we need a 2 and a 1. Not happening. And if this is 3, well, you can just forget about it. There's no way to put this as 3 and have the other two be 1 apart, or to be not touching, because you need 4, 3, 1, 1. And that's just not working either. So this guy is not part of the region, period. And that makes the only candidate for this purple. And now we have to look at where can the final red cell go. This is actually a black edge. Well, it's technically also green, but... And we'll just draw some more black edges. There's a black edge here because we already have a 4 in the red region. So this is just how it finishes off the red region. Great. And so now this has to be the brown region, because if it's anything else, the brown region is too small. So this is the brown region. And the brown region has to grow like this. If we ask ourselves where 1 is in the red region, it's here. So now if we ask where it's in the blue region, or sorry, in the brown region, this brown region, it's here. Just by Sudoku. Now. There's a couple more things that we can do. Yeah, we're 3 in the brown region. There we go. I want to ask what this brown cell, this cell I'm highlighting is. Whatever this cell is, it has to go here. Because that's the only place it can go in the blue region. Whatever cell this is, it has to go here. That's the only place it can go in the orange region. Because it can't be 3. And this can't be 1, 2, 3, or 4. So yeah. So this is 5, 6, 7, 8, or 9. But see how it sees a 5 here. How it sees 6 here. So that's not allowed. And it can't be a 9. Oh yeah, because it just sees a 9. Okay. This is 7 or 8. This is 2 or 3. And this is also 2 or 3. Well, this is also true by Sudoku. Because you see this guy. This orange guy. Can't have a 2, 3. Nor can blue, so it's these guys. Okay. Now let's establish a brown and yellow can't be part of the same region. If they were part of the same region, size 9, 2 plus 7, and this 1 is stuck all by itself. So this, 2 plus 7 is 9, 2 plus 7 is 11, 11 plus 7 is 14, 14 plus 7 is 16, 16 plus 7 is 18, 18 plus 7 is 19, 19 plus 7 is 20, 20 plus 7 is 21, 21 plus 7 is 22, 22 plus 7 is 23, 23 plus 7 is 24, 24 plus 7 is 25, 25 plus 7 is 26, 26 plus 7 is 27, 27 plus 7 is 28, 28 plus 7 is 29, 29 plus 7 is 30, 30 plus 7 is 31, 31 plus 7 is 32, 32 plus 7 is 33, 33 plus 7 is 34, 34 plus 7 is 35, 35 plus 7 is 36, 36 plus 7 is 37, 37 plus 7 is 38, 38 plus 7 is 39, 39 plus 7 is 40, 40 plus 7 is 41, 41 plus 7 is 42, 42 plus 7 is 43, 43 plus 7 is 44, 44 plus 7 is 45, 45 plus 7 is 46, 46 is a black edge again. And now these regions have to chase each other to escape. Boom, boom. So something like this happens. And now I want to talk about this brown Fillomino, this brown Palomino, because we've been looking at the brown region so far, but we can actually look at the brown Palomino. 1, 2, 3, 4, 5, 6. So there's a green edge here, and so it has to grow here. And there's also a green edge here. And now you see how these green guys are part of the same polyomino? We established that a long time ago, because this guy has to grow out to here, because it's touching a 1. This is also a green edge, because if it weren't, then this would be a 9 cell region, which is bad, because this can't be 9. Okay, so this polyomino is completely bounded. It has to be a 7. Size 7, so boop, boop, boop. Okay, and now here's the thing. This is a black edge here, because if it's not, it enters into here. This is at least 3. Bad. 7 plus 3 is 10. 10 is greater than 9. Much harder to reason is that this is a black edge. Now, we'll go over why. Here's the thing. If you enter here, then this becomes a black edge. So, you have a 7, and this guy has to go here. This has to be a 2-cell polyomino. So it has to be a 2, which makes it a 3. But this is 2 regions, not 3 regions. Bad. So what we get is that both of these are black edges, which means that this brown and green region, they combine, and so we'll combine them, and that creates a black region. Oh, I suppose I should explain why this is a black edge first. I'll do that. This is a black edge because if it weren't, then we have a 1 polyomino, a 7 polyomino, and then we need another 1 polyomino. Only way to get that is from one of these guys. That's not possible because then it would also have a 1 in the cell, and the regions would conflict. So this is a black edge. And then everything I said about these black edges becomes easier to understand. This is green. This is yellow. These edges get drawn. Yeah. Cool. Okay. So this is 2, this is 3. And we're going to draw this edge. And well, let's look at what this can be. This can't be 2 because we already see there's more than 2 polyominoes in the yellow region. It could be 4 or 5. It can't be 5 because 1 plus 3 plus 5 is 3, or is 9, but that gives us 3 regions. So it has to be a 4. Alright. And now these guys aren't part of the same polyomino. Because it's either like this is a 1 and this is a 4, or this entire guy is a 4. Regardless, it has to go out here. Another way to reason actually that this is a black border is if this is yellow, it can't be 1, 2, 3, or 4. So it has to be at least 5, but that's already too big, so that's bad. And this is a black edge because you can't have 2 squares in the same region. So now we've actually determined the entire yellow region. Okay. So this is something and this is something. And these guys are the same. So let's look at what they can both be. It can't be 1, 2, 3, 4, 7, so it's 5, 6, 8, 9. Obviously it's absurd to have a region of size 9. It's absurd to have it's absurd to have 9 regions. You also can't have 8 because that implies you have 1 region of size 2 and 7 of size 9, and you just can't fit that many around a region of size 2 because the regions of size 1, sorry, the polyominoes of size 1 can't touch each other. So this is 5 or 6 for now. And now what we're going to do is, well, this is obviously a 1. This guy can't grow into here, 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 and it can't grow into here. So this is a green edge, but this region has to go into here. and this region has to climb out into here. And since this is blue, let's just say this is, I don't know, orange. Blue and orange are different, obviously, because, well, squares can't be in the same region. And then now there's a pink that's either part of blue or orange. Okay. And now let's look at this green region. One can only go here. In fact, there's a lot of irregular Sudoku we can do right now. This is 4 has to go here. And okay, so let's look at this column here, column 9876. We have to find 5 in here in column 5 because it can't go in pink, and the C is here in red. So these guys are both 5. Well, now column 6 has nowhere to put 5, so these guys are both 6. And this is actually pretty constraining because 6 is a lot of regions to have. In fact, I think it's the most you can have. So this is really forcing, which is really promising. Anyway, now we're going to do some regular Sudoku and look at where 1 can be. Because we have 1, 2, 3, 4, 5, 6, 7, 8. Oh, we have 8 not ones. Yeah, this is the last one. That's just Sudoku. We had that a long time ago. It's fine though. Okay, so we have blue and orange are in different regions. Let's have pink have a complement. I don't know what to make. There's no region that's far enough. Oh, we'll make it gray. We haven't used gray yet. Okay. So this is gray. And purple is just doing its own thing. I also forgot to draw this edge. That's fine. Purple's doing its own thing. Okay. Cool. It turns out I think we can do a bit more. Okay. Yeah, in terms of the region construction, it is not possible for blue and purple to be in the same region. Let's go over why that is. Yeah, it just doesn't go fast enough. 1, 2, 3, 4, 5, 6, 7, 8, 11. The taxi cab distance is just too great. It would have to traverse too many cells to reach here, and therefore these two are different regions. We know that blue and orange are different regions, so we have this. Awesome. Now, we see this pink region can either be blue or orange. And regardless, I believe that it has some common characteristics as to how large it becomes. Okay. If this guy is blue, then this guy has to be orange. Right? Oh, just kidding. I'm trolling. Blue, blue, blue. Oh yeah. Okay. If this is pink, if this is blue, then this has to be blue. Otherwise, boom, size 8 region. Too small. So this is blue. If this is blue, this is blue. If this is orange, this has to be orange. Because if it's blue, then, well, LOL, it's cut off. So yeah, pink has to go here. Because if it doesn't, then pink goes here, regardless of what color it is. Blue doesn't work. Orange doesn't work. This can't be blue. It can't be orange. So, yeah. This has got to be pink. Can't be gray. Because otherwise, you know, which is bad. Bad things happen. So this is pink, and this is a black edge. No, sorry, it's not a black edge. Likewise, this is also not gray, because if this is gray, and this is orange, this is blue, blue. Did I lie? I lied. I think that can be gray. I think it's this that can't be gray. Yeah, this can't be gray. Because if this is blue, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, no, it can't be gray. I lie again. Okay, anyway, so we do have this, though. This is for sure true. And now I think we can do some searching for where 2 is. Uh, can we? Or do we have to hunt for more regions? We might have to hunt for some pesky regions. Which is slightly cumbersome. Um, okay, I know something interesting, maybe. Is that you have an X-wing of 4s. Sort of like this, or not this. Like this in the green and purple, or green and pink. Speaking of purple, you know what? Why don't we make this purple so there's like minimal confusion? Cool. The X-Wings and 4s I don't actually think helps. I think I'm just missing something major right now, but I forgot. Uh, I'll tell you what. I actually know in column 4 where 2 is. That's the major thing I was missing. Let's look at this pink region. Where's 2 in the pink? It has to go here. Oh, actually, I know exactly where it goes. Because oh, okay. Now let's look in column 4. Where does 2 go? Can't go here. Can't go in green. Can't go here. Could go here. Can't go here because it's 2. Can't go here because of red. Can't go here because of this. So 2's here. And the crucial thing is that it's like really limits what this can be. Can't be a 6, can't be a 7, can't be a 9. We already established that 8 is ridiculous. So this is 3, 4, 5. And now what can this be? 3, 4, 5, 6, 7, 8. This is 3, 5, 6, 8, 9. 9 is ridiculous. 9 and 1. So we have 3, 5, 6, and 8. Now what I want to do is establish that 6 and 8 are ridiculous. Notice how these guys are in the same polyomino. So it can't be 6 or 8. Let's establish that. It is very obviously not 6 or 8 if purple is blue. Just because we need 6 regions. It is not as obvious if it's orange, but let's talk about orange for a second. If it's orange, then you can't have 8 because then that gives you 2 regions. 1 plus 8 is 9, but we have 3 regions. So this can't be 8. And this can't be 6 because if this is 6, you have a region of size 1, a region of size 6, and a separate region of size at least 3. And why is this the case? Well, it's because the orange region has to be constructed like this. So, yeah. It would look like this, and there's a 3, so... And this guy can't reach here quick enough, so it's bad. and this can't be 6, regardless of what region it's in. Okay. And now, like, after we do some whittling down of possibilities, this is sort of a hardish step. Um, and it's this. This guy can't be 5. Um, and here's why. If this is 5, then this is 3. And we'll actually discuss why this is. If this is 5, this is obviously not part of this blue region, so this is part of orange. And so we already established what the orange region will look like. It would look like this: 1, 5, 3. Again, this and this 5 and this at least 3 region can't join up. So 1 plus 5 is 3. This is 3. And the reason this is really bad is because now let's look at rows 2 and 3. All right. The only place row 2 can get its 3 from is from the green region. But the same is true of row 3. So that puts 2 3s in region green, and that is really bad. So this can't be a 5, because this would cause this to be a 3, and this would cause both this and this to be a 3. Bad. So this is just Sudoku. It's pretty hard, though. This is like a step that is just kind of hard to see. So this is a 3. Yeah. Which means that in the orange, or in the green region, let's actually get rid of these 4s. They're not super useful. And these 5s for now. Green region in 3 is... Sorry, the row 2 is up here. It's in the green region. It's 3 in the green. It's in the 3 in the green region is in row 2. Okay. And now let's look at row 5. Or sorry, I meant row 4. Let's look at row 4. It can't go here by Sudoku. Can't go here by Sudoku. Can't go here because we have the green region. Can't go here, orange region. Can't go here by Sudoku. So this is 3. And now we've established that purple and orange are different. So purple is blue and gray is orange. And if this is orange, it cuts this off. That's bad. So now this is... Okay, so it basically establishes the colorings. And you have 1, 2, 3, 4, 5, 6, 7. Okay. So this couldn't possibly be orange. It's too far to be blue. Like, also, it cuts it off. This can't be blue because this will cut the oranges off. So this is orange. So now we have a 7 and a 7. Yeah. And now we want to analyze what do the blue and the orange region actually look like. And our key here is this big 6 clue. It does a lot. And, okay. So, first things first is that with this 3 region, we kind of need 1, 1, okay, 1, 3, 1, 1, 1, 2, right? This is a 1, this is a 3, and then whatever's next, or not diagonal, we need a 1, a 2, a 1, and a 1. And what's the reason for that? Well, it's just largely because it's not possible to really have... Well, okay, no, this is actually the only possible partition. Like, irregardless of all the region construction shenanigans, the Fillomino rules, because you're partitioning... Well, you're partitioning 9 into 6 things. Two of those things are 1 and 3. That's equivalent to partitioning 5 into 4 numbers. So it is beyond these guys, it's 1, 2, 1, 1. Or 1, 1, 1, 2. And so we need to find a way to construct this 3 polyomino that allows for a 1, a 2, a 1, and a 1. Or 1, 1, 1, 2. Um, so like anything like this is super janky and not allowed. Right? We can't like have any isolated 2 regions because then the 1 regions we have left would touch each other. And in fact, this shows that these two have to be the same polyomino, because if they're not, this happens bad. 2, and then 1, 1, and then we're out of places to put 1s. So this has to be connected. Okay. And now we have 2 options left. It's either this is our 3 Fillomino, or this is our 3 polyomino. Let's look at this. This is bad because this would be orange. In fact, actually, let me establish one thing. Whatever polyomino this guy is a part of has size at least 3. It is touching a 1 and a 2 polyomino, and it cannot be part of this 3 polyomino. So, regardless of what happens with this 3 polyomino, this is an orange guy. And so this is a blue guy, because if this is orange, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and these guys are blue, and that's really bad. This is blue. If we make the polyomino look like this, now, okay, sorry. If we make the polyomino look like this, we're really only left with one way to split this up, is to do this. Dot, 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 do, 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 do. I'm sure there's a cleaner way to think of this. Yeah, no, this is a bad argument, I think. There's a cleaner way to do this for reasons that are outside of my understanding right now. I'll think. It feels like this should work, but I know there's some reason it doesn't. I just don't think this can be blue. There's some chaos construction reason. Hold up. Let me think. Use my 3 brain cells. I'm sure it's because of some Sudoku shenanigans. Yep, okay. Let's look at where 3s go. 3 in region pink goes here. But it just goes here because ding, ding, ding. Oh, these guys are just DQ'd from existence. So you get an X-wing here, actually, of 3s in the green and the red region, and we have 1, 2, 3, 4, 5, 6. Feels like I should be able to find 7. 2, 3, 4, 5, 6, 7. Okay, yeah, 7. Okay, so we're done with that. I'm definitely missing something. Yeah, I'm missing something really obvious right now. I don't know what it is. It's supposed to be a solution guide, but I don't even have the solution in my head. Oh, I think it's actually like what's not possible is this. This is not possible. And why is it not possible? Okay. Yeah, this isn't possible because it's forces. It's not because of chaos construction. This isn't possible because you have this Palomino is forced like this. You can't get 1-1-1-2. Like no matter how hard you try. This is just really bad. So it has to be like this and this. And now there's two possibilities. Either this or this. But let's actually look at this guy. This cell cannot be a 1 polyomino, so it has to grow into here. So this is at least 4. Uh, Brilliant. Incredible IQ. Okay, and now let's look at the blue region. Where does 4 go? Um, Not here, not here, so 4, 4. 2, 4, and now let's look at where 2 goes. Here in this region. And I feel like I'm really just staving off like some observation I have to make. 7 goes here. Like, I'm doing Sudoku, but none of it actually matters. Um, there is some key observation that's just not popping in my head at the moment, and it's important. And it's probably about the orange region. Okay. Uh, okay. I'm pretty convinced that this guy can't be a 1 polyomino. Polyomino. Let's draw our black borders. I'm pretty convinced that this cannot be the case. This cannot be the case. Because it forced this and this guy to both be 2 polyominoes, right? And we can only have room for... Okay, no, this is not true. It forces this. But forces this to be 2 polyomino. Bad. Because now we have another 2 and a 1. Sad. So this goes here. Er, this, these guys are connected. Um, for similar reasons, I think this can't be a 1 polyomino. Because then this is a 2. And this place has at most 2 polyominoes. So we're left with at most 2 here. Which is bad. Oh, am I lying? Could it work like... No, I'm kidding. Yeah, that's at most 2, because 3 plus 1. That's bad. So this edge, also this line goes here. So this is either 2 or this is a 1. Or it's a 5 and it's a 1. A lot of possibilities. Oh, but this is a 3. And this would be touching a 3 if it stayed at 3, so it has to be at least a 4. And now we've determined the construction of the orange guy. Okay. Yay. So this cannot be a 1. It must be connected. That's a 3. So now there's only one way to put down a polyomino of size 2. Like this. Such that the rest have size 1. I.e. the rest of the squares aren't touching. It's like this. So this is our polyominoes. And now, for the 4, you can only construct the 4 region like this. The 1 region can't go here, it has to go here. So, Now, we have done a super. Oh, we haven't actually finished this region. We should figure out what this region is. Okay, this is at least a two. This is at least a two. This is at least a two. But if this is a three, it's just okay. It has to be two, one, two. Um, because otherwise you're just not gonna have enough regions. This is two, one, two. Okay, great. We figured out most of our region borders. I feel like this would have been easier if we knew the region construction for the red region, but it's okay. We got there regardless. So yeah, now we've done basically most of the puzzle. And now all that's left is just finding where digits go. Just Sudoku. That's the easy part. And now I'm clueless. This is not good. Uh, am I gonna have to pencil mark every cell? Oh, this is awful. Okay, fine. I will cave. I will do that. I will pencil mark every cell. Oh, just kidding. This is a 7. It's only 7 in column 1. Like, only place 7 could be. 5, 6, 8, 9, but this is not a 6. No, I think we could do Sudoku like a good person right now. 7 goes here in column 8 in red region because it has to be in somewhere in row 8. So how many threes do we have, by the way? Oh yeah, we have 7. We have this X-wing that we can't resolve. Santa 7. Oh yeah, I now we can look at column 2. Where's 7 in column 2? Here it is. And now we look in column 4. Where's 7 in column 4? Uh, only could be here. Where's 7 in this column? Column 6. Here it is. We found all 7s, and now we found all 3s. Because our X-Wing got broken. Yay. Uh, okay. And now we found 4. And now where's 4 in column 6? 4's here. 5, 6, 8. But this is not 6. This is not 5. It's not 5. Oh, yeah. 5 in column 6 as well. 5. 6, 8. Great. So yeah, you kind of just have a pretty difficult irregular Sudoku left. 5, 6, 8, 9, 6, 8, 9. 6, 8, 9. What am I missing? I am missing a 2. And that two's location is very obvious. 5, 6, 8, 9, but it's not a 6. Not a 6. Not a 4. Oh yeah, 4 also here. It's fairly obvious. I guess it's 5, 6, 8, 9. It's not a 6. Uh, okay. So 6 in column, or 6 in red region has to go down here. So this can't be a 6, which means that also there's an X-wing of 6s here with the orange and purple region, so uh Actually, then there's an X-wing here. That's not helpful. Barely helpful. It's not 9 though. That's for sure. Okay, you know what? We're just gonna mindlessly pencil mark everything for now. I'm sure if you're actually good at Sudoku, you can do this much better. I am not. I'm not good at this. So oh yeah, now this is the gnarly part. I think we have to do some coloring to actually deduce. Oh yeah, this is the 8-9 pair. Pfft, okay. So this is it's the only place 6 can be. Yes, that 6. It's 6. That's a 5. That's a 6. 6, 6. That's not a 5. That's not a 5. Okay. We get to do coloring now. Because we already have all the regions, I'll just erase all the surface elements. It's fine. We don't need them. We'll color the 8-9s because, like, it's useful to find, like, weird eliminations that way. Oh, and now look at this region. I'll color it blue again. Where is green in the blue region? Here. So, this is green. Yay. Now we must ask, where is red in column 1? Can't be here. Well, okay. In fact, I'm going to color this region blue. Green sees this guy. Bop. Red sees this guy. Bop. So this is 5. And now I think our coloring has served most its purpose. Has it? Maybe. This is 5, so this is red. Oh, nope, hasn't served its purpose yet. Here's a 6. 8, 9, and now the coloring resolves itself. But the coloring was useful for the brief moment it lasted. 5, 9, 8, 5, 8, 9, 6, 9, 5. Okay, so we're almost done. We just need to crap. Crap. That's okay. I have a solution. And it is to fill it back in. Okay. So there's actually one thing that we should do. And it's okay, I'm gonna reconstruct what we had because I deleted my Sudoku elements for no reason. I'll reconstruct what we kind of had. It needs to be green, 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 and we didn't have this border. Okay. Okay, so first of all, we have a couple of little regions. We just need to finish up some Fillominos. And what I meant to do is I meant to clear surface elements. So every region's okay, including this one, because this just is a 9-cell polyomino, except for this region. You see how a long time ago we said it's a 6, a 1, and a 2? We didn't know where the 1 and the 2 are, but see how this is a 2? This is a 1. And now answer check says all digits filled out, green edges for region borders, and double edges for pentomino borders. Yeah, because that's just how answer check works. I would like to do it differently, but it doesn't work like that. So just to check the answer check agrees with us, we'll first convert these green edges into doubles. Pop, 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 pop. And then we're gonna convert these black edges just to green edges. Oops. Okay, and now we have green edges. And answer check activates, which means I'm gonna get rid of some annoying little pencil marks. Do they want to go away? I suspect not. Okay, this congratulations message is gonna pop up every time. 8, 6, 9, 6. Okay, so yeah, this is at the very end what the puzzle looks like. I'll recreate the regions. But yeah, um, thanks for giving this puzzle a go. Um, it's a bit hard, that's why I made the walkthrough. I hope that either whether you're like someone who's already solved it and just wants to see maybe the best logic for some steps, although I definitely missed something good at some points. Like, I literally forgot some of my own stuff. Or whether you just needed hints from this video to help you along. Either way, hope you enjoyed.